Hi, everybody. So, this is just always my favorite time of year. I love to review factoring. And so, I know we've been reviewing in class, but I decided tonight that it might be helpful if I put one video together, just kind of a quick review of everything. So, here goes. And there's Coach Fred. You can see me smiling, can't you? All right. So, the first thing that we always want to do when we factor is to first look for a greatest common factor, a GCF. And I say GCF it. That means pull the GCF out to the front. So in my first example, I'm looking at it 6x squared plus 10x. Well, I know that 6 and 10 have a factor of 2, but there's also the x to consider. So there is an x in both of them. So I want to make sure that I'm taking that factor into account as well. So my GCF would be 2x because both x squared and x have an x in them. All right, then it's like backwards distributive property. So I'm going to be left with a parentheses of what, like if I distributed that 2x through, I would get the 6x squared plus 10x. So I told you that one way for you to figure out what goes inside is to just divide those numbers by the GCF. So if I divide 6x squared all over 2x, the x's are going to simplify, and the 2 is going to go into the 6 3 times, so I'd be left with 3x. All right, and then if I simplify 10x divided by 2x, the x's cancel, and 2 goes into 10 5 times. So it would be plus 5. Now you may be noticing a couple of things. The binomial you're left with has to have the same number of terms you started with, and it does. It's got 2 terms. Now, if you want to check, you can FOIL, or you can distribute, multiply right here. If I distribute that 2x through, I'm going to get 6x squared plus 10x, and there I've checked it, okay? All right, let's look at the next example. I look at the numbers first, 7 and 21. Hopefully you're seeing that 7 is the greatest common factor. Then I look at the variables, and in this case I have a y cubed and a y squared. So you look at the variable, the least number of times it occurs in each of them, or the most times it occurs in each of them, and it's y squared. So 7y squared. And I'm going to divide to see what we get. I know my binomial is going to have 2 terms in it. The y's here are going to cancel down to 1. The 7's cancel to 1, so I'm going to be left with a y. These y squared cancels, and 7 goes into 21 3 times. So y plus 3. And again, you can multiply to check if you need to. All right, so that's basic GCF factoring. Let's move on. Onward. All right. Then we talked about that very cool special factor pattern that I love so much called the difference of squares. Remember, the word difference means subtract. Squares means perfect squares. And we talked about that there's a lot that you need to know. And I'm going to start at probably about 9. So how about square root of 81 is 9. So 9 squared is 81. So 81 is a perfect square. We've got 100. We've got 121, which is 11. 10. We've got 144, which is 12. We've got 169, which is 13. I also said it was helpful to know that 225, which is 15, and 400, which is 20. And I think you can do the ones before 9. I think those are the ones that you guys always remember. Okay, so we look at it. Step 1 is always to look for a GCF, but I don't see a GCF with 4x squared and 81, no GCF. So then I say, is it 2 terms? And it is. If it's 2 terms, is it the difference of squares? So in this case, I see 4 is a perfect square, 81 is a perfect square, x squared is a perfect square, and they're being subtracted. So it is the difference of squares. So my factor pattern is I'm going to have one binomial with plus, one binomial with minus, and it's whatever the square root of the terms are. So the square root of 4x squared is 2x, so 2x and 2x. And the square root of 81 is 9, so 9 and 9. So again, there's that factor pattern, the difference of squares that's going to keep coming up. All right, looking at number 2, let's look at it. All right, well, number 2, I do see a GCF. They both have a common factor of a 4. So step 1 would be for me to pull out that GCF. I'd be left with x squared minus 9. I will be looking for that step. I do not want you jumping to the final factored answer. All right, then I look at what's left and I say, can I factor it further? And looking at it, I see that x squared is a perfect square, 9 is a perfect square, and it is subtracted. So that is the difference of squares. So I'm going to be left with then x plus 3, x minus 3. All right, so usually the difference of squares is a pretty easy factor pattern for kids to understand. My other one that I really, really like is that perfect square trinomial. So a perfect square trinomial is a trinomial, so it has 3 terms. First and the last term are perfect squares, and the middle term is double the roots of the outer terms. If it is a perfect square trinomial, then it will always factor to, in this case, a plus b quantity squared. So the square root of the first and the last terms and the sign of the middle term, quantity squared. All right, so how do we check? Here are the questions that I kind of ran through today in class, and I want you to think about, okay? So the first thing you do is you say, is the first term a perfect square? And it is. Is the last term a perfect square, and is it positive? It is. And I'm going to just take the quick square of them. So 2x and 5. Is the middle term twice the product of the roots of the first and last term? Meaning, is 2x times 5, that's 10, is this term double it, regardless of what the sign is? And it is, because 2x times 5 is 10x, 10x doubled is 20x. So it is the difference of squares. So I know my answer is going to be a binomial squared. It's going to be the square root of the first term, which is 2x, square root of the last term, which is 5, and the sign of the middle term. So 2x minus 5 quantity squared would be my answer, because it is a perfect square trinomial. I know my voice is terrible. Can't help it. I'm getting tired. It's late. All right, let's look at it. I see a trinomial, so I say to myself, is it a perfect square trinomial? All right, is the first term a perfect square? Yes. Is the last term a perfect square and positive? Yes. Okay, so their roots are p and 7. All right, and there should be a p right here. Is the middle term double the root of those? The double 7 times p, and it is. So it is a perfect square trinomial. So it's a binomial quantity squared. Square root of p squared is p. Square root of 49 is 7. Sign in the middle term is negative. Done. Done. All right, a couple more. Don't forget, we still always have to check for the GCF. We get into this rut where we jump to wanting to do those. So I look at this and I see that they're all even. And so I pull out a GCF of 2. I'm left with 4x squared plus 4x plus 1. Now I've got to ask myself, it's a trinomial. Is it a perfect square? Is it a perfect square trinomial? So, is the first term a perfect square? And it is. Is the last term a perfect square? Yes, 1 is a perfect square. And it's positive. And if I take the root of 4x squared, it's 2x. The root of 1 is 1. If I double that, is it 4x? And it is. So it's a perfect square trinomial. So I can factor it to a binomial squared, which is 2x plus 1. Sorry about my dog barking in the background. He loves to bark. All right, so we go through the checklist. The checklist is really, really important, guys. I mean, it is. Have you gone through number 1 and to check if there's a GCF? If it's 2 terms, is it the difference of squares? It may not be. X squared plus 25 is not the difference of squares. It's 2 terms. But it's not the difference of squares, it's the sum of squares. There's no factor pattern for this. Not factorable. All right, if it's 3 terms, is it a perfect square trinomial? But what if it's 3 terms and not a perfect square? Then what? All right, so that's what I'm calling trinomial factoring. So as a reminder, this should be an X. Sorry about that. We look for the factors of 32, the things that multiply to 32 that add to 4. So I'm going to go through all my factors. 1 and 32, 2 and 16, 4 and 8. Is that it? I think that might be it. All right. And I'm going to be making 2 binomials because the coefficient here is 1. I like these the best. I know it's going to be x and x. And then I use the smiley face method to help us. So looking at it, the only ones that I see here that can add to 4 would be 8 and 4. So I've got an 8 and a 4. I know they need to multiply to give me a negative 32, so I know 1's going to be negative. And in order for them to add to a negative number, the 8 would need to be negative, and that 4 would have to be positive. All right, but I check. Does negative 8x and positive 4x, does that give me a negative 4x? It does. I've checked it. So I am done and factored. All right, keep moving. X squared minus 2x minus 63. Oh, these factors are bigger. 63. I've got 1 and 63. That's not going to add to 2. I've got, let's see, 3 and 21. That's not going to add to 2. But you might be seeing right off the bat that it's 9 and 7. 9 and 7 do add to 2, and 9 times 7 give me 63. So, love it. First term's a coefficient of 1, so it's x and x. I put in my smiley face, put in my 9 and my 7. They multiply to a negative number, and they add to a negative number, so one's negative, one's positive. In this case, the larger term would have to be negative in order for them to add to a negative 2, but I'm going to multiply them anyway just below to check. Do they indeed give me a negative 2x? They do. I've checked myself, and so I've factored it. Okay. You try. Everybody try this one. See what you get. Press pause if you need to, and then we'll come back. All right. So you've tried it. You've pressed pause. And I'm noticing that these are bigger numbers, 84. I know I've got 4 and 21. That's not going to give me 5. 7 goes into it, doesn't it? 7 goes into it 12 times. Ooh, and 7 and 12 would be factors that add to 5. So I have A and A, 12 and 7, smiley face in to help me. I need them to add to a positive 5, but multiply to a negative number, which would mean the 12 would need to be positive, the 7 would need to be negative. I check myself regardless if I see it or not, and I get a positive 5A, and I'm good to go. All right, last but not least, the harder stills. The harder stills are when that coefficient in front of the x squared is not a 1, okay? If they're not a 1, the rules kind of change. All right, so this was when I said you make your two binomials, but now we got to look at the factors of 2, which are 2 and 1, and 9, which are 9 and 1 and 3 and 3. We always are going to start with the first ones first. So we get 2x and x. Then I jump to putting my smiley face in to help me connect the numbers. All right, so I start with the most common ones first. I'm going to start with the 3's, and so I'm going to put in 3 and 3. And then I'm going to multiply it. And on the outside, I get here a 6x, and on the inside, a 3x. That is not going to give me a 9x. And if I flip them, it's not going to matter because they're both 3. So that means that I might have to jump now to 9 and 1. So I'm going to erase. I'm going to try the 9 and the 1. So I'm going to put 9 here and 1 here. I'm going to get a 9x and a 2x. Oh, I can get those to add to a 7x. If the 2 is negative, then they will give me a 7x. So the 2's negative would be here, the 9 positive would be here, and I have factored it. All right, last one. I gave some big numbers here. Why? Because I really want us kind of thinking about these bigger numbers and seeing if we can do it. All right, so my first term, I know it's a binomial. There's no GCF. It's not a perfect square trinomial because 14 and 5 are not perfect squares. So I'm going to look at all my factors of 14, which are 14 and 1 and 7 and 2. My factors of 5 are 5 and 1. All right, so I'm not going to work with the 14 and 1 first. I'm going to try the 7 and 2 first because they're the most common numbers we're used to seeing. So we get 7x and 2x. I then go ahead and put in my little smiley face to help me, and I've got a 5 and a 1. So I'm thinking about this, and if I put the 5 here and the 1 here, I'm starting to see that I'm going to get a 10x and a 7x. Now, the fact that this is positive and this is negative, they have to multiply to give me a positive and add to a negative means they both have to be negative. So negative, negative, and I check here, negative, negative, it does give me negative 17x. So I am good. All right, guys. So I want you to look at this last one and try it. 4x squared plus 16x minus 9. So I go through my process. Is there a GCF? No. It's 3 terms. Is it a perfect square trinomial? I don't know. Let's see. 4x squared is a perfect square. 9 is a perfect square. But that is not positive. So it is not a perfect square trinomial, so we want to be extra careful. Threw that one in there as a trick. All right, so I go through my factors. Factors of 4 are 2 and 2, 4 and 1. Factors of 9 are 3 and 3, and 9 and 1. All right, I'm going to try the 2 and 2. Why not? Okay, so I'm going to go 2x and 2x. And if I do 3 and 3, I already can see that I'm going to get 6 and 6, which is 12. So I'm going to try 9 and 1. 9 and 1 gives me an 18x and a 2x, which actually does give me, I can get that to give me a 16x. And it's a positive 16x, but they have to multiply to give me a negative. So then 2 would have to be negative, and the 18 would have to be positive. So it would be minus, plus, and I'm done. All right, so that's it for now. That's a quick review. Oh my gosh, that's like 4 days of factoring from Algebra 1. Yes, we've been working on it the last couple of days, but I just wanted to give you kind of a whole overview of that factoring, and hopefully that helped tonight, okay? So bring questions and see me for extra help if you need it, okay? Have a great night.